Hello and welcome back to our fourth video in the hardware topic. In this video we're going to spend a few moments actually looking at the components found within the CPU, the central processing unit. Now, we talked in the previous video that the CPU is like the brains of the computer, and that applies very much indeed, because just as the human brain has two distinct halves, so does the central processing unit. Here on our whiteboard is a very simple diagram of the central processing unit, the CPU. And as I said just a moment ago, the CPU has two distinct halves. One is known as the arithmetic logic unit, or ALU, and the other half is that of the control unit. Now, the arithmetic logic unit, its job is calculations, so that's multiplying, dividing, adding, subtracting, and comparisons, such as looking at more than, less than, equal to, and so on. Its job is also to control the speed the calculations done within the CPU are carried out. It will control the speed of the calculations. The control unit, its job is to coordinate all the parts within the CPU during the processing of data. Its job is also that it needs to be responsible for being able to having that data actually processed. So it has to coordinate everything in the CPU for the data to be processed, and it's responsible for making sure that the data is actually processed. It has a third responsibility of what is called the fetch and execute cycle, and we will look at that in a future video, but it's essentially making sure that data goes into the CPU, that work is done on it, and that work data is then sent somewhere or saved somewhere. Here we have a couple of smaller boxes. Now, just as when we want to go and do some work and we need a workbench to be able to do our work, the CPU has similar things. These could be regarded as workbenches. And these workbenches within the CPU are called registers. Here is a program counter register. Here is an instruction register. And we will look at the function of these two registers shortly. But a register is essentially a high-speed memory location where data is stored either just before or during the actual processing of that data. The program counter register has a particular job, and its job is to keep track of the current instruction, and when that instruction leaves the program counter to go to the instruction register, the program counter will then go and point to and collect the next instruction. The instruction register we'll talk about when we look at the fetch and execute cycle. Finally, we have something called a system clock. Now, the system clock is a quartz oscillator. It's a small device attached to the motherboard. It sends out a regular pulse. So you can imagine its job as being like the conductor of an orchestra. Just as the conductor will put out a steady beat so that all parts of the orchestra are going at that pace, the system clock does precisely that. It sets out a regular electronic pulse. As a result of that, it's controlling the timing of when each instruction is registered. So essentially, when an electric charge meets the central processing unit, it's almost like a little alarm bell goes off, and that informs the central processing unit, the CPU, to go and do some work. Now, this pulse is going very, very quickly indeed. It's not so regular. It could be billions of pulses per second. But the system clock's job is to make sure that everything is working, that all the components of the computer are synchronized and are working at a regular beat. So what we have seen there is that the CPU has lots and lots of different parts. Now, once upon a time, there used to be one central processing unit in a computer. But what has happened over the years, we can get more than one central processing unit in a computer now, so that things can work quicker. So, for example, you could have two CPUs in one area, and that would make it dual core. Similarly, if you would have 4 central processing units within a computer, so it works really, really quickly, then we refer to that as being quad core. When we actually measure the speed of a CPU, well, they are measured in hertz, which is essentially a pulse. A CPU are now measured in gigahertz, which is billions of pulses per second. So, for example, we could have a CPU of 3.5 gigahertz, which would mean that there are essentially 3.5 billion pulses of electricity going into that CPU every second. So for every pulse, the CPU is doing some work. So at 3.5 billion pulses a second, it's doing a lot of work. So in this video, we've looked at the various parts of a computer, that being the arithmetic logic unit, control unit, registers, and the system clock. Thank you. I'll see you in the next video. Bye-bye.